Okay, here's a video reassessment for uniform circular motion. So the question I chose was, consider a bend in a level highway with a radius curvature of 250 meters. If the coefficient of static friction between a car's tire and the road is at 0.4, what is the speed at which the car can take the turn? So we first draw a picture of the car turning. See, it's like this with the radius here. And if you convert that into a free body diagram, we're going to have the normal force pulling up, the force of gravity down, and the force of static friction in the positive direction. So the formulas that we would use would be the static friction formula, which is the coefficient of static friction times the normal force. We know here at the maximum, it's going to be the coefficient of static friction times the normal force, which is going to equal static friction. So if we go down here and find, let's see, we know that the normal force equals mass times gravity. And if we go to the x component, the force equals the mass times acceleration. And we know that the force of static friction is going to equal the coefficient times the normal force. So if you set that equal to the acceleration of the formula for the acceleration of a circular motion, which is mass times velocity squared over r, you can find your answer. So here we have the coefficient of static friction times the normal force, which is mass times gravity, which is equal to the acceleration, which is mass times velocity squared over r. And then if you solve for the velocity, you would get v equals the square root of the coefficient of static friction times gravity times the radius. And if you put all the information in, it will give you 31.3 meters per second. And for part 2, it says at what angle would the highway need to be banked so that the car could make the turn at the speed calculated without needing to rely on friction. So if we draw another free body diagram, we see we have the normal force this time going this way with the force of gravity down, and here's our angle theta. So the y component would be the force equals mass times acceleration, which we know the acceleration is going to be 0. And then you can get your formula from this. So the normal force times the cosine of theta is going to equal mass times gravity. And the normal force is going to equal mass times gravity over the cosine of theta. So right here. And then for the x component, the force equals mass times acceleration, which is going to come to the normal force equals sine of theta equals the acceleration, which is mass times velocity squared over the radius. And if you put those all together to get one formula, you would have mg over the cosine of theta times the sine of theta, which we know is tangent, and that equals the mass times velocity squared over r. So the m's would cancel, and you would get tangent of theta equals the velocity squared over r g. And then theta, if you solve for theta, it would be theta equals the inverse tangent of 31 meters per second squared divided by 250 meters times the gravity, which is 9.8 meters per second. And then your theta would be 21.8 degrees. So it would have to be at 21.8 degrees.